Hello and welcome back. Um, I have made in the past a video about how to use MATLAB Simulink with stm32, um, but um, maybe it was not clear enough explained. So I'm attending another video. So this time with a real example. Okay. So let's define our task. So I want to just blink an LED. So blink an LED when a button is pressed. Okay, so this is simple, very simple task for today. So let's, before jumping in Simulink, let's build some code to blink it without MATLAB first. Okay, so just ignore the code which is here. We will make different one. Okay, so we will choose this file, model sense interface.c, for our function definitions. So okay, let's start by creating a function which will get the button state. Alright, so unsigned the get button state. Okay, we will not have here. Okay, then we will define here a variable which will represent the button state. Okay, then let's take my particular button, it's this one. Okay, yes, this one, and like so. Okay, so if this condition is true, then the button state equals 1, which means on, else the button state is off. Okay, then we will just return the button state. Okay, so nothing more. Okay, good. Then so far we have the input. Then we need to drive the LED. All right. So let's make another function which sets the LED state. All right. So like so. Okay. Good. So now we will just shortly use this statement. So if state equals 1, then we will have my particular LED. We will set this one okay, MBS like so. 7, yes. Okay. Else, let's just copy this one here, and we will clear. Okay. What is the problem? Syntax error. Okay, so I have here a parenthesis. Yeah. Good. So good. So we have this function here which will drive the LED, alright, based on this button state. Okay, not a very big deal here. Good. Now let's just make a short test. So we will go to the so I have the prototypes here predefined, so we are good. Then we will just go here and declare a variable and the state equals 0. So this is our then let's call it button state. Okay, so equals it will get the button state. Okay, so then we will call set LED state. BSD. Okay, good. So basically, well, I can comment out this one. We don't need this for this particular example. So we basically I have an interrupt here, which triggers at each 10 milliseconds. Okay, good. So okay, let's build this. Good. Let's program it. Okay, so basically this needs to work. I will just add here a window and let's try it. So I will go now to press the button and yeah, there it is. The blue LED is off and on based on my input. Okay, so I will just now remove this one and go back to Simulink MATLAB. Okay, I will open here MATLAB, and basically here I will just make an empty model. I will just copy this one. I have already one which I'm working on it, but I will just make a copy and call it this Blinky. Okay, so let's open the Blinky model and basically I don't want to process the button, okay, but you can think about some other implementations that you may um, need to do in Simulink, like some debouncing and other stuff. My purpose is to read the value from the button into Simulink and just drive the LED. Okay, good. So I have this model which I will delete, and I will have an empty model, input and output. Okay, first thing to do here is to go into an M file, which I have already one here. It is sense.start. Okay, so again, this is my model. It's an empty model, like I said, and then we will just let it like so for a moment, and we will go back to this sense.start. Okay, so here we need to define okay, we can get rid of this. We need to define the our input signals. Okay, so Networks provides an with the real-time workshop so-called MPT signals. Okay, so let's make an MPT signal. I will just okay, choose a name. Okay, so I will get okay button state. Okay, and this equals to MPT signal. Okay, then I need to specify here the storage class, which is my name that storage class gal equals custom. Okay, basically I have already defined here, so I will not spend so many time. I will just copy okay this and rename my okay okay, so this is my input. Now just we need to be careful here what header file. Okay, so our header file it is this one, model sense interface.h. So this contains our prototypes. So we need to say here mdl how sense interface.h sense interface.h. Okay, so this is the first step. Then we need to specify the get function name. Okay, the get function name is the name of our function, so it's get button state. Okay, good. So our name is get button state. Okay, good. Then we will need to define the data type. So the data type is unsigned 8. Good. So basically, we need also to specify the set function, but we will not use it. Okay. Good. Then basically this is it. Start. This could be also set to -infinity. No problem. No problems with this version of MATLAB, but I think this will be a problem starting with MATLAB, a higher version. In 2016, this it could not be infinite no longer. Okay, so basically this is it. We need to define the header file and the name of the function along with these all configurations. Okay, good. Now then we need to define the output. Okay, so the output is the same. We will just copy this one. Okay, here. Then we will choose a name. Our name is set LED state. Okay, so good. Now we'll just replace the name here. Replace. Good. Now again, what header file do we use for the set? So the definition is in, again, model says interface.c with the prototype in the H file. Okay, so it is correct here. Good. Now the get function is not used but is set here. Then we will need the name of the set function, which is set LED state. Good. And the output data type is again unsigned 8. Good. So basically this is the minimal settings that you need to do, okay, before going to Simulink. Okay, now let's open our Blinky model. Good. Let's, I don't know, because I don't want to enter something in between. Let's just enter a delay, maybe. Okay. Unit delay would be enough, I think. Good. And then we need to go to properties, okay, and specify the name of the signal. The name is this one, get button state. All right. Maybe I need to make it a little bit, to zoom a little bit, maybe. Okay. Oh, seems that it doesn't work. No. Anyway, good. So we have this delay here. We need to specify the name. So the name for the input is get button state, apply, okay, and signal name must resolve to Simulink signal object. Okay, apply. Okay, so this is the input. Then we need to specify the output name of the signal. Okay, so the output is set LED state. Okay, then we will just set the name here and resolve to Simulink object. Good. So basically this is it. Let's run a little bit to see if we have some errors. So first we need to run the M file. Okay, so then as you can see here, we have the get button state and set LED state defined as empty signals. Let's just run the model to see if it all is okay. Okay, it seems that I have an error. Cannot propagate bus signal from output to input because the destination of block expects a busing with different structure than. Okay, this means that the data type here is wrong. I will just inherit. Okay, good. Again. So as you can see, it runs. Yeah. Good. So now the next step would be, so we created the empty signals in the M file. We created our model. Okay, you can add anything you want here in between the input and the output. Then the next step will be the code generation. So I have made a previous video on how you can generate code. So for me, I will just modify the name for which I want to generate some code. Okay, so where is it? Since adaption. Okay, I will just say here Blinky. Okay, good. Then just run it. Let's see what happens. Okay, okay. So now, yeah, also the report was generated, but we don't need this. We need to take a look here in the so my script successfully copies all the files into the Eclipse environment. Okay, so let's make a refresh. So as you can see here, we have successfully copied the blinky private.h, blinky types, blinky.c, and blinky h. Okay, the blinky h contains blinky c, sorry, contains the our logic. Okay, so as you can see here, let's make another zoom, maybe. So let's make just a short compare. So when we called the functions, we had similar something like this. Okay, get the button state and call. So we had the BST in which we save the state of the button and just call the set LED state. Okay. In our case, we have here a delay, good, which we have the set LED with the blinky. This is the structure anyway, and here then we will just get the button state, so it's somehow delayed. Good. Now let's just call this. So as you can see, we have two main functions. So one is the blinky step, which is the cyclic functions, needs to be called cyclically, and the initialized blinky, okay, which initializes the model. Okay, so let's just go back to main and erase this. Okay, I think let's call the init function, which normally needs to be called outside. So yeah, we can do it here with no problem. Okay, good. Then we need to call the step function, which is blinky step. Okay, good. One more thing before compiling would be to include the blinky that h. Good. I think we are good to go. Okay, let's now make a short test. So we need to program this onto our Nucleo board. Good. Now let's press the button. Okay. So I think we are done. So as a just short recap, this video presents a very simple way on how you can interact between stm32 microcontroller, or okay, this is a particularly, but you can interact with any controller to blink an LED using MATLAB Simulink along with the embedded coder. So thank you very much. If you have some questions, please feel free to comment, and thank you very much. Bye.